Let's study this circuit in which we have three inputs called A, B, and cell. Cell stands for select, and one output X. And the circuit is composed by three gates, one OR gates and two AND gates. And in the first AND gates, the second input is negated. You see this circle here, and negate bottom yes. So it is as if there was a NOT gate on the second input here. Now let's try how this circuit works. And you can see that now if I click on the input A, the output X follows exactly the value of A. And in this case, the input B is irrelevant, is not important, is disabled, because anything I do on B doesn't have any effect on the output. And vice versa, if I put a 1 into cell here, now A is disabled and B commands governs the output X. So this selection input allows to choose between one of the two other inputs. If select is 0, we choose the input A. If select is equal to 1, we are choosing the input B. This particular circuit is called multiplexer. And in general, a multiplexer is a circuit with multiple inputs and just one output, and also with some extra select input, which allows to select one of the other inputs. Now I want to show you the truth table of this circuit. I'm going to project and analyze circuit. And of course, our truth table has 8 rows, because we have 3 inputs, and 2 raised to the power of 3 makes 8. And in this particular case, I want to rearrange the input of the truth table. I'm going here to inputs, and I'm going to move the cell input to the first position in the table. So you can see now the first column of the table is cell. And you can see clearly that the output X is equal to A when cell is 0. The first 4 rows of the table, X is exactly equal to A, and B is irrelevant in this case. And in the next last 4 rows in the table, when select is 1, the output is equal to B, and the value of A is completely uninfluenced, not relevant for the output. But there is also a shorter way to write this table, and I'm going to show you in a moment. So you can see this is a particular way to write a truth table. In this case, you see that when select is equal to 0, the value of X is A, so is equal to A. If A is 0, X would be 0. If A is 1, X would be 1. And when select is 1, the output X is equal to B. So this is a shorter way to write our truth table, and in my opinion is much clearer, much clearer and easier to understand. And now I'm going to show you a cool feature of Logisim. First of all, I'm going to rename the basic circuit, the circuit which is named main by default. I'm calling it MUX, max, for multiplexer. And I'm going to create a new circuit, max2. And in this new circuit, completely empty, I drag the first subcircuit, this one. So you can see now we have a box, a square box, which represents the circuit we have done before. So inside this box, we have all the circuit of the multiplexer. You see here I have A and B and select and X. So I can see all the input and output of the circuit, but I cannot see anymore the components which are inside this box. So I'm going to show you that now I can use this circuit as if it was a component of Logisim. So, for example, I'm going to put two input buttons here, one here connected to the first input and one here connected to the second input. And I'm going to have a LED connected to the output, and then an output pin here, sorry, an input pin here connected to the select input. Now, if selected 0, the first button connected to A is active, enabled, so you can see that whenever I push on the first button, the LED is flashing, and the second input in this case is disabled. But if I put a 1 on the select input, now the button which commands the output is B. And so you see this is a cool way to use our circuit. If we build a circuit, we can use it inside another circuit without having to see all the details of the circuit. All details are enclosed inside this box. And now I want to add one more circuit to our file. I call it demux, which stands for demultiplexer. Demultiplexer is the opposite of the multiplexer, and the circuit is really simple. Again, we need 2 AND gates, and the first gate has the second input negated, and the the first input of the 2 gates are connected together. You see the point which stands for a connection, and you can rotate all the components using the arrows on your keyboard. It's a very quick way to rotate. And here, and I need a select input, which I rotate in this position, here and here. So in this case, this is A, and this is cell. And we have 2 inputs. This is the first circuit we have encountered till now, which has 2 inputs and not just one. And I call this input X, output, sorry, X and Y here. So let's see how does this circuit works. When select is equal to 0 and I click on A, I see that the value of A is transferred to the output X. And when I put a 1 on cell, the value of A is transferred to the output Y. So this circuit is the opposite of a multiplexer. It is called demultiplexer. In a demultiplexer, we have just 1 input and multiple outputs, and a select input which allows to choose which outputs we want to use. So if I put 1 on the select, in this case I am using the output Y, and if I put 0, I'm using the output X. So let's see the truth table of this circuit. And in this case, the truth table has just 4 rows because we have just 2 inputs. And you can see that we can reorder like before. I put the select input first, and I can see that when select is 0, the output Y is always 0, is disabled, and the output X is following the values of A. And when cell is 1, vice versa, the output X is disabled and the output Y is following the values of the input. And now I'm going to add one more circuit to our project. So the new circuit is called MUX demux. And in the circuit, I'm going to drag one multiplexer and one demultiplexer in this way. And I connect the output of the multiplexer to the input of the multiplexer. I use just one select for both the circuit here. I connect two buttons to the two input of the multiplexer as done before, here and here. And also I want to use two LEDs connected to the two outputs of the demultiplexer, here and here. And let's see how it works. When cell is 0, the first push button is enabled and the second push button is disabled. At the same time, the first LED, the upper one, is enabled and the lower one is disabled. So in this case, you see, when I click on the first button, the first LED is flashing and the second button is not working. If I select one here, now is the second button which commands the second LED in this way, and the first button and the first LED is disabled. So you can see we can use many different sub-circuits together to realize a more complicated circuit, hiding all the details of the implementation of this circuit inside this box. This is very, very useful. It's a very, very useful feature of Logisim.